Josh Allen and Will Scher, and we are doing our 357 project number 1. It is a LED sound level indicator. The first part of our circuit includes a 100 kilo ohm resistor with the goal of protecting our microphone. In our circuit, we are using a varying resistance microphone that changes its resistance based on the volume of the incoming sound. The varying resistance mic converts a noise into a measurable voltage pulse, which is then sent through our 741 op-amp. The signal from the microphone gives us pulses with amplitude of approximately 10 millivolts. To amplify this signal, we put it through a 741 op-amp, which uses a feedback resistor to feed some of the amplified signal back into the op-amp input to change the amplitude of the op-amp's output. The degree of amplification, or gain, is determined by the ratio of our 1 mil feedback resistor, R3, to the total resistance of the incoming circuit. Our measured gain is approximately 200 for this circuit. The 741 op-amp can only output approximately 40 milliamps, but to get to the circuit to power 2 LED lights, we needed more current. To increase the current through the LEDs, we installed a 2N2222 transistor. The output of the 741 goes into the base lead. The collector lead of the transistor is connected to the LED number 1 and then to the positive 15 volt terminal. The emitter terminal is connected to the LED number 2 and to the ground. The current through the base coming from the 741 controls the much larger current moving through the collector to the emitter, which then controls the brightness of our 2 LEDs.
Lastly, let's take a few looks at our circuit in action. Testing. So it's putting off my phone too. Nice.